Hi guys, this video is about samples and populations and biased and unbiased. So we're going to start off with a lot of vocabulary. If this goes too fast for you, feel free to pause it and write down all the vocabulary and then come back to listen. So the first thing we're talking about is a population. A population is an entire group of people or objects. So for instance, if we were concerned about our governor race, our population would be all the residents in Mississippi because only the residents of Mississippi would vote for the governor of Mississippi. A sample is a sample part of that population. For instance, all of the residents of Flowood, Mississippi would be a sample of all the residents in Mississippi. This could also be different if we were worried about our presidential race. Our population would be all the residents of the United States. And all the residents in Mississippi would only be a sample. So these things can change based on what you're actually looking at. So keep that in mind, that something that is a population can also be a sample. Then we have unbiased and biased samples. Unbiased samples are representative of your larger population. They're selected at random and they're large enough to provide accurate data. A biased sample means a sample that is not representative of a larger population and favors certain parts of the population. For instance, a biased sample may be if we were trying to conduct a survey of the students of Hartfield. If we only talked to girls, that would be biased. If we only talked to seniors, that would be biased. If we only talked to 2 kids, even if they were chose randomly, that would be a biased sample because that wouldn't be an accurate representation of the whole population. It's just not a big enough sample. So those are all things that can make samples biased. Unbiased samples are used all the time in real life. When you do research, you would like to have unbiased samples. So these are some examples to determine, we're going to determine whether each is biased or unbiased. So first we have to estimate the number of students in your school who play a sport outside of school. You decide to survey the players on the boys' baseball team. Well, this is biased. It doesn't account for females at all, and it favors athletes. So your data would be skewed probably in the toward the sports outside of school. Number 2, Katie would like to approximate the number of students in her school that own a pet. She decides to survey 5 students in her homeroom. Well, this is biased. Her sample is only 5 people out of who knows how many attend her school. It's probably not a large enough sample. They're also all in her homeroom, which could play a part there. The yearbook committee must choose among 3 different themes for this year's yearbook. To help make their decision, they survey 100 random students during lunch. This is unbiased. It's large enough. 100 students is a lot. It's random. It says the word random. And we're guessing that they did this, like in our case, over the different lunches to represent all of the types of students that attend the school. And number 4, the New England Patriots and the Atlanta Falcons played in the 51st Super Bowl. To determine which team was the favorite to win, a New York City newspaper surveyed 500 residents. Well, this is a biased sample because it targets a certain area. In New York City, they probably like the Giants or the Jets. They maybe don't like the Patriots. They maybe don't like the Falcons because it's too far away. There's no telling. But it is, since it's a specific area, that would be an issue. So, predicting outcomes. The results of an unbiased sample are proportional to the results of a population. So you can use unbiased sample results to make predictions about the population. Biased sample results should not be used to make predictions about the population. And this gets complicated in real life based on the research. You would hope that when they talk to you about results and things like that they're using an unbiased sample. So here, sorry about my dog, 5 members of the marching band, number 5, members of the marching band Plan to sell cookie dough to raise money for new uniforms. They survey 60 students at random to determine their favorite type of cookie. The results are shown in the table below. So they surveyed 60 people, 21 voted chocolate chip, 12 voted peanut butter, 9 oatmeal raisin, and 18 sugar. So what percent of the students prefer sugar cookies? My proportion is 18 out of 60. Remember to convert a fraction to a percentage. You divide the numerator by the denominator and multiply by 100. You get 30%. On B, what percent of the students prefer chocolate chip or peanut butter cookies? So I'm going to add those together, and I get 33 out of 60, which is 55%. If the band orders 500 tubs of cookie dough, how many tubs of sugar cookies should they order? This is like making predictions with theoretical or experimental probabilities also. You set up your proportion with your original, so here we're going to use our sample. So we have 18 sugars out of 60 total equals X over 500, because this is how many our total population is. And we get 60X equals 9,000 when we cross multiply, so X is 150 tubs. Here on number 6, 75 random 8th grade students were surveyed to see how many text messages they send each day. The results are shown in the table below. So in our frequency table, we have our results. What percent of the students send 51 to 75 text messages each day? So that's 25 out of 75, which is 33.33%. What percent of the students send no more than 50 text messages a day? That's these 14 and these 4 together. So that's 18 out of 75, which is 24%. And then C, if there are 450 total students in the 8th grade, how many would you expect to send at least 76 text messages a day? So that would be 32 out of 75 of our sample population is equal to X over 450 of our total population. You cross multiply and then divide, and you get 192 students. And then finally, a group of middle school students were randomly chosen and asked about whether they were going to attend the school carnival. Of these students, 65% said yes. So they're giving us the percentage, and they kind of want us to work backwards. So if 52 students responded yes, how many students were surveyed? So with percentages, remember, they're always out of 100. So what we're looking at here for our percentage is 65 over 100 is equal to 52 over X. We want to find out how many total students were surveyed. So we're looking at our part on top, which is 52, over our whole, which we don't know yet. So we're going to cross multiply, and we get 80 students. Using this same percentage, if there are 1,600 students in the school, predict the number of students who will attend the carnival. So again, with predictions, we're going to use our sample. In this case, 65 out of 100 is equal to X over 1,600. When you cross multiply, you get 1,040. Just for informational purposes, this would work if you use 52 over 80 also. You are welcome to do that if you want to, but it does require that extra step of finding the total number or having how many students responded yes. So that's it for samples and using unbiased samples to predict outcomes. Let us know if you have any questions. I hope y'all are having a great day. Bye.